Consider the pattern 5, 8, 11, 14, etc. We're going up by threes, plus 3 and plus 3, etc. So this here is a linear growth. And we're not dealing with y's and x's, but we're using n representing your y, and we have AF plus B, where A is your slope, F used to be your x's, and we're talking in general about n, where n represents the number at a particular figure number. So if we're to think about this, we have n, which is your y value, is equals to the slope, and the slope is a number that it goes up by, which is 3. F is the figure number, and we want to fix it by plussing or subtracting some number. If we suppose figure number is 1, this is figure 1, figure 2, figure 3, figure 4, etc. When we substitute 1 for f, 3 times 1 is only 3. We need to move up to 5 by fixing it, by adding 2 more. So this here is the holy grail equation that's going to let you figure out any figure, including the 100th figure. So the number of blocks, or the number, is equals to 3 times the figure number, 100, plus 2. So amazingly, we know right away there's going to be 302 as our number. Way over here, the figure is going to be 100, and the actual number up here will be 302. So continuing this idea of linear growth, we have an actual picture. This is figure 1, figure 2, figure 3, and you can see that we're adding 3 squares each time. So we have plus 3, and we just keep on adding 3. So we're going to say that y is equals to mx plus b, and the slope is increasing by 3, and we don't need a b. It's essentially plus 0, because when we're talking about x equals 1 or figure 1, we actually have the right amount already. So in figure 43, we have y is equals to 3 times 43, which is 129. Now for question number 12, the question is, how long is a line segment below? So this is like trades math. You take the bigger number and you subtract the smaller number, which is between 2 and 4. We'll say this is 3. What is 8 minus 3? The length of this piece of wood is simply 5, and that's how long the line segment is. Now do these points, essentially 0, to 1, 5, etc., do they actually represent a line? And what we're looking for here is the pattern. This is plus 1, uh-oh, we have plus 2. So normally we're adding only 1, and here we're consistently adding plus 3, plus 3, plus 3, and we know when it comes to the slope, which is rise over run, for this table of values to be linear, we must have a consistent pattern, and we don't. So we're just going to say no. Now for this last question, 14, we actually do have a line, and so we need to find the missing value here. Now unfortunately the pattern is not so consistent. This is plus 4, plus 3, so it's a bit of a mystery. But what we do know is that we do have 2 points, and given 2 points, negative 2, 3 and 2, 15, we can find the slope and the equation. So the slope is rise over run, which is 15 minus 3, over 2 minus negative 2, which is 2 plus 2. So we have 12 over 4, which is 3. Let's use slope point form. Y minus y1 equals m, x minus x1. And it doesn't really matter which point we use. Why don't we just try using this point here? So y minus 3 is equals to 3x plus 2, because x minus a negative number flips to become positive. Let's use distribution. Y equals 3x plus 6. And when we throw the negative 3 over, we have another plus 3. So the final equation is y equals 3x plus 9 is the actual line equation. So now when we substitute the x value of 5 into here, we can solve it. Y equals 3x plus 9. Let's substitute 5 into the x value, and so now we have the y value, which is question mark. 15 plus 9 is 24, and we solved this mystery number.